Now, this is the question that I was trying to, you know, ask to make you a reference of the class 11th limits and continuity chapter. So this is a beautiful question, in fact. Discuss the continuity of the function x plus 2 and minus x plus 2. So go through this explanation, right? And then in the given question, we have a very similar, well, not a very similar one, but almost. The graph goes like this, then turns up like this, right? The question is not actually based on limits or continuity. The question is rather based on, is this graph representing actual possibility of a physical motion, or wait, what did I say? Um, does this graph represents a motion which is physically possible? Yeah, exactly. Like in the real world, is it possible, or is it an ideal thing to say? So apply this concept here into this graph, and then extrapolate to the given question from O to A, O to A to B, B to C to D, and try to apply these things that you've learned in this graph here. Well, to make it short, as you're thinking right now, check whether this graph is continuous or not. But then apply that to kind of brainstorm yourself that if this, although this is possible by a continuous function, can it actually represent a motion which is physically possible? Okay, so pause for a minute or two, go through this, make a note of this as well, and then try to think of, visualize about this motion here. Okay, I hope you have spent at least some time to understand what it is. Now keep all those thoughts aside. Let us focus on only on this explanation now. Okay, so what we have here is these points which are very important to understand, which is from, yeah, point, these are the points. Point A, instantaneous velocity at point A, instantaneous velocity at point E, and instantaneous velocity at point G. There's something special about these points A, E, and G, which is of course related to continuity. What is that? To understand that, we'll have to, focus only on that path and the points A, E, and G. A, E, and G. Only the corner points. So let us focus completely on OAG now. Now, for this triangle, OAB, if we draw it on a graph paper separately, can consider only OA and AB. We have x1, y1, x2, y2, one pair, x1, y1, x2, y2, another pair. So we'll consider OA and AB separately. How? Let's pick OA first. For the line segment OA, we have the coordinates x1, y1 and x2, y2, and also the slope as y2 minus y1 by x2 minus x1, right? What is y2 and y1? It is minus 5 and 0. So it is minus 5 minus 0. Similarly, for x2 minus x1, we have 1 minus 0. Therefore, the slope of this line is minus 5 by 1, which gives us minus 5. So, to put in a different word, a different way, slope of OA at A, or slope of OA, before A or towards the left of A, the slope is minus 5 by 1. Okay. Now, what happens after A? Again, we have 2 points, which is x1, y1, x2, y2. Slope is y2 minus y1 by x2 minus x1, which is minus 5. Sorry, my bad. Let me just write it down here. So y2 minus y1 by x2 minus x1. What is y2? 0 minus what is y1? It is minus 5 here. 0 minus minus 5 divided by 2 minus 1. 2 minus 1, which gives us plus 5 divided by 1. So, right, this here. We can say that slope of a from the right is 5 by 1 and from the left is minus 5 by 1. And what would this imply? This actually means that approaching from the left, slope is minus 5. Approaching from the right, slope is plus 5, which further means that the left hand limit is the reason why we were going through this text, right? Exactly. The left hand limit is not equal to the right hand limit. And when left hand limit is not equal to right hand limit, it means function is not continuous at a. When the function is not continuous at a, it is neither differentiable, which means derivative doesn't exist at a. And therefore, what is the derivative? This is the derivative of displacement time graph, which gives us velocity, and therefore velocity doesn't exist at a. What does this mean? This means that at the point a, having coordinate 1 comma minus 5, limit t tends to 1 minus dx by dt, which is the velocity, is not equal to limit t tends to 1 plus dx by dt, which is velocity. Or in other words, velocity at t minus 1 is not equal to velocity at t plus 1 for very small instance. Therefore, instantaneous velocity at t is equal to 1 is not defined. The graph implies an instantaneous reversal of velocity from minus 5 meter per second to plus 5 meter per second, which would require infinite acceleration. Hence, the motion is an idealized model and not physically realizable at that instant. Okay? So yes, we're just trying to include some, integrate maths as well. Now, to go further, at every corner point of a displacement time graph, where two straight segments meet with different slopes, the left hand and the right hand limits of velocity are unequal. Hence, instantaneous velocity is not defined at all such corner points such as A, E, and G. Okay. Now, what I would suggest is try to draw this graph one more time in your book, right? And follow the graph to find out average velocities from O to A, B, C, D, E, F, all the way up to H. Try to find out the instantaneous velocities at C, D, D, E, E, F, and instantaneous velocity at GH as well. Okay. So please make sure that you don't skip this. Doing these kind of questions repeatedly will take a lot of time, but then the kind of confidence it installs in you is something which will stand the test of time. I can guarantee you that the concepts that you learn after investing this much of time is something that you'll never ever forget, let alone for your JE means. Okay. All right. Now, moving on to, okay. The next question is something that's based on differentiation. And okay, let's see what do we have here.